Sugar cane sweet, but girl, your love is sweeter. So
Welcome to another of STEM classroom communication. Today we are looking at another of STEM topic, our subject, mathematics. And the topic we are looking at today is an interesting topic. It is interesting because it cut across its usefulness cut across all levels of education from primary down to university level. There's no at no level in your mathematical career or expository that you will not come across this particular topic I'm about to treat now. We will have it in part 1 and we also have it in part 2. And for part 1, we are looking at standard form, part 1, expression and finding A and N. Standard form, part 1, expression and finding A and N. At the end of this lecture class, communication, we are going to know what A stands for and what N stands for. Before I really go into the topic, let me quickly highlight to you some of the areas of importance, benefits, significance of this particular topic. One of them is that when you are dealing with extremely large or extremely small number, extremely large or extremely small number in the count of multiple of 10, then you need to deploy the use of standard form. Otherwise, the numbers will be too large, too cumbersome for you to handle. What do I mean? For example, we have numbers that are mega. That is capital letter M. These are numbers that are to the power of 6. That is in millions. We have those that are micro. That is micro. Those are numbers that are to the power of negative minus C. That is numbers like 0.000000000 before you begin to have digital number. Those are extremely large. The ones that are negative are extremely small. The ones that are positive, the exponent is positive, those ones are extremely large. You can have something like nano. That is exceedingly far smaller than micro. That is small n. Nano is 10 raised to the power minus 9. Okay, then we have kilo. Kilo is a bit smaller than mega, that is 10 raised to the power 3, and so on and so forth. So when we have mega or micro, small or large number like this, then we make use of standard form. It means that expressing numbers in standard form make large number to look so simple for you to be able to handle. Then finally, there's a topic in mathematics that is called indices. Most problems on indices are better expressed in terms of number in standard form, because in indices we have a number that is called power or index, which has a base and it has an exponent, something like a cap. When you have a cap on your head, the base, exponent. So this is relevant in the study of indices, and if you look at that with this, you can see that it looks so much alike, and it looks so much alike with what I have here. A times 10 raised to the power n. This is power. It has a base 10 and it has an exponent n. So what this a and this n stand for in expressing a number, any number in standard form, we are going to see very soon. That's my guess. Okay, so let's go straight to the topic now. Having intimate you with the relevance, the real life application. But don't forget that here we teach with real life relational teaching techniques. Real life relational teaching techniques. That means everything that we must expose you to, we must relate it to your immediate environment, the areas of application. Thank you. Now look at this. Standard form 1, expression and finding A and N. Now, if you are given a number, any number, and you are asked to express it in standard form, the abbreviation of standard form is x dot small letter f, standard form. Anywhere you see, it could also be significant figure. We also use this in significant figure, but in this case, it is standard form, s dot f. If you have to express a number in standard form, do you know what it means? What it means is that you should write the number as this, as a times 10 raised to power n. I take that again. A times 10 raised to power n. That's what they are simply asking you to do. And so, for this particular topic, standard form, you must know this expression here. Okay? Now, what does A stand for? Look at what A stands for. A is the first single non-zero digit before the decimal point. I take that again. A is the first, underline first, the first single, that means one digit, first single digit, non-zero, which must not be zero before the decimal point. Every number must have a decimal point, either between the digits or at the end of the digit. Then n, let's look at what n stands for. N is the count of shifts of the decimal point to the right or left. Look at the diagram here. Let's say the decimal point is here, and I needed to shift the decimal point to come just before A. If I shift towards the left, can you see it towards the left? See the arrow? It will be, the n will be plus, positive. If I shift it towards the right hand side, the n will be negative. That means this n will be negative. Is that clear? Alright, now let's take an example. We will look at 4 different examples. At the end of these 4 examples, those of you that are connected to this particular platform, to this YouTube channel, to this TSP online schooling and coaching program, you have the opportunity to answer these questions and send it to me for assessment, for evaluation. For you to be fully part of this schooling and coaching program, the opportunity it will be rolled out for you at the end of this video. Okay, the method you need so that you can be registered with us. Our charges are not too discouraging. Okay, thank you. Now we'll start with an example. Example 1. Express a number like this. Express this. 231 million in standard form. 231 million. You know, million has 6 zeros attached to it. 231 million in standard form. We need to write it as this to conform to this. Now, if you look at this number, there's no decimal point in between the digits or zeros. It means that the decimal point is at the back here. It means that the number is 231,000,000 points. Since the point does not appear anywhere here, then that means it is the full stop. That is the point. Is that clear? Now A is the first digit. If you look at this number, the first digit, which is non-zero, is this 2. So it means that this decimal point has to shift from here to this place. We have to remove this point here and come and put it here. Because A must be a single digit, one digit, single. Then there comes the point. That is the meaning of what I've just told you the other time. So let's see the shifting now. See the how to do the shifting. 1, 2, 3, 4, 5, 6, 7, 8. Look at the point. The point will come here. So it means that this number will now become 2.31. All these zeros will disappear. We don't need it again. Times 10 raised to power. How many places have you shifted this? 1, 2, 3, 4, 5, 6, 7, 8. I'm shifting it towards the left hand side. That means n is plus. That will be 10 raised to power plus 8. 10 raised to power plus 8. Do you see that? I'm shifting towards this direction. That's why it's positive. Plus n. So if I ask you, what is a after writing this number in standard form? A is simply 2. What is n? N is simply plus 8 or 8. You remember that when you say plus 8, it also means 8. The positive sign attached to any number can disappear. We already know that it is there as positive. So this is the first example. Second example. Okay? Let's look at another question. Look at this. I want to give you a number like this, 0.000081 in standard form. Express 0.000081 in standard form. We are to write it as a times 10 raised to the power n. Now, let's see what happened here. A is the first non-zero digit. That means A, you will ignore all this one and come to this place. So this is our A. That 8 is our A because it's the first single non-zero digit before the decimal point. So it means that here the decimal point is here already. So they will told you where the decimal point is. But this decimal point must come immediately after this 8. So it must come here. It must come between 8 and 1 because it must be immediately after 8. Immediately. So let's see the shifting. Can we go? Yes. 1, 2, 3, 4, 5. The point will come here. I'm going towards this direction, to the right. To the right means the power n will be negative. So that is 8.1 times 10 raised to the power. Let's do it again. 1, 2, 3, 4, 5. 10 raised to the power minus 5. It is minus. Exponent is negative because I'm going towards the right hand direction. Can you see that? It means that this number now, you can see that it looks more simpler compared to this. That is this number in standard form. The third example. Like I said, I will just give you 4 examples to round up this topic. Now, let's say I give you something like this. 280.009 in standard form. Express this in standard form. Again, if you look at this, the first digit before the decimal point, we are having 3 digits, 1, 2, 3. But in standard form, it should be a times 10 raised to the power n. Where this a is just a single digit, and which is the first one. So the first digit here is this 2. It means all this other one must come after the decimal point. But look at where the decimal point is. It means you have to shift the decimal point immediately here. We need to bring it here. Do you understand? We need to bring the decimal point here. So it means that we need to shift it like this. Look at this. 1, 2 to the left. That means to be 2.80. Now you will not ignore all this one because there is a digit here. 0.009 times 10 raised to the power 1, 2 plus 2. Now, how do you mean this 9 is not there now? All these 0 will have just cancelled. It will have become something like 2.8. Approximately, this is just like 2.8. Okay? Times 10 raised to the power 2. Because after the decimal point, look at it, what will have is 0, 0, 0, 0. Even if you approximate this one to 1, it will be 1. If you approximate this 1, it will be 0. So all this one turn to 0 will disappear. You can see in standard form, very shortened. It looks so complex like this, but it's shortened here. In this case, what is our A? The first digit, 2. What is our N? Coincidentally, it's also 2. Okay? Then, finally now, what if I give you something like this? What if I give you something like this? 5.13 in standard form. Look at this. So what we do now? Express 5.13 in standard form. Meaning you have to express it as a times 10 raised to the power n. Okay? Now, if you look at this, a must be the first single one, non-zero digit, before the decimal point. If you look at this, Already this one is already a single digit, just one. And immediately after that, you have decimal point. It means that this number is already in standard form. Okay, that is 5.13. So times 10 now, 10 raised to the power what? Did I shift it? No, we didn't. No shifting. You can't shift it because it's already in standard form. That means it will be 0, raised to the power 0. Hello? Anything raised to the power 0 in mathematics is 1. So 1 times 5.13, it will still give you 5.13. What is A raised to the power 0? 1. What is Nigeria raised to the power 0? 1. What is Russia raised to the power 0? 1. Because there can only be only one Russia in the world. There can only be one Nigeria in the world. You, what is your own name? Okay, you said Toyosi. Okay, Toyosi raised to the power 0 is what? 1. Because it is only your kind of Toyosi that exists. No other Toyosi that can compete with you. Am I communicating? So anything raised to the power 0 is 1. Okay, let me give you a puzzle now. What then is 0 raised to the power 0? What is 0 raised to the power 0? What is emptiness that is being capped, that is being honored? Somebody that is empty, you are not capping that person, not to make him the king, because that's the meaning of exponent. This n means like you are capping somebody. If you cap somebody that is empty, what do you think it will give you? Will it give you 1? Connect with me on my YouTube channel, get registered, and then I will tell you what the answer to 0 raised to the power 0 will be. Now, this class is actually meant for by curriculum to students in junior secondary school 2, JSS 2. Then it is relevant across board from primary school to GSS, SS class, down to the university, like I said the other time. Also in SS1, they will also come across this. So, like I told you, there is no level that this is not relevant to. This is relevant to even to students in primary 3, 4, 5, 6, down to the senior, all the advanced program, Olympiad student, SAT, what have you. This is an important topic for you. So till we meet in my next video, do have a great day.